Alright, in this particular video we are going to go over radicals and exponents through a unit test. Alright, so right now if you can't see it, it says the square root of 24 b cubed times the square root of 40 b squared times the square root of b squared. Now whenever you're multiplying radicals together, all you have to do is make sure that the numbers that are inside of the radicals can be multiplied together. Alright? So all I'm going to do is underneath one radical, I'm going to multiply the 24 times the 40. Then I have b cubed times b squared times another b squared. Now whenever you're simplifying a radical, radicals always look for groups of two. For example, if I said like the square root of 4, that breaks down to a 2 and a 2. That's why the square root of 4 is 2. So even though you can't see it in this little index area right here, so this section right here is called, that number would be called the index. Even though you can't see it, it's a 2. So right now let's break down into some of our factors here. Hopefully you know 24 breaks down to 8 times 3, and 40 breaks down to 8 times 5. So you have an 8 times an 8 times a 3 times a 5. Square roots look for pairs, so we have a pair of 8s. And if we were to list out all of our variables being multiplied together, we have a total of 1, 2, 3, 4, 5, 6, 7, because there's 3 of them, 2 more, and 2 more. 3 plus 2 is 5, plus 2 is 7. We're going to look for pairs. 1 pair, 2 pair, 3 pair. So what comes out of this radical? An 8. We've got a b times a b times a b. That's a total of b cubed. And what stays on the inside? We've got a 3 times a 5, which is 15. And then we have one more b that does not get out of the radical. So this is going to be my final simplified answer. Okay, so just a quick little review. If I have, say, for example, the square root of 12, the square root of 12 breaks down to a 4 and a 3. The 4 breaks down to a 2 and a 2. So I have a 2 that comes out, and I have a 3 that stays in. So this would be considered simplified. Okay, this is unsimplified, this is simplified. But if I'm dealing with variables, like if I say x to the power of 5, if I say what's the square root of x to the power of 5, well, what does x to the power of 5 actually mean? It means I have x being multiplied to itself 5 times. Square roots look for groups of 2. So what comes out? An x. What else comes out? Another x. Out of the radical, I have x squared, because x times x is x squared. And on the inside of the radical, I have one little x that did not have a buddy. Now sometimes, okay, you might just say, hey, okay, if you want them to come out of the radical, come out on this side. Good. Come out of the radical on this side. That's fine. You got to multiply these together. So x times x is x squared. So on my particular problem, what I'm going to type in is I'm going to type in 8b to the power of 3, or 8b cubed, radical 15b. 8b cubed, radical 15b. 8b cubed. And then I'm going to put another radical right here and put 15. And then I think there's one b left. Yep. Okay. I'm going to go back there and I'm going to do one more right here. I'm going to start with this guy. It says simplify. All right, so if we have a radical, it says we're going to simplify the square root of 52 x to the power of 4. Now 52 can be broken down into a 4 and a 13, and 4 can be broken down to a 2 and a 2, and x to the power of 4 can actually be broken down to x squared and an x squared. So I got a pair of x squareds and I got a pair of 2's. So a 2 comes out, an x squared comes out, and the only thing that I have left standing is a 13. So it's 2x squared radical 13. So let's say you're a person that's like, I am not good with factors. Here's a cool little trick you can do in your calculator. You hit y equals, you type in the number that you're looking for, you divide it by x, and automatically you hit the table. You can see you have your factors. 1 and 52, 2 and 26, and 4 and 13 are the only factors. I chose 4 and 13 because 4 is what's called a perfect square. All right, so we have 2x squared radical 13 is going to be the answer for this guy. 2x squared radical 13. All right. Next question. We have the square root of 42. And then there's whoa, a. Fine, I won't draw there. I'll draw somewhere else. Sometimes my board is a little finicky. All right, 42, a to the power of 4, b to the power of 6. Now 42 breaks down to a 6 times a 7, and 6 breaks down to a 2 and a 3. And hopefully you'll see that, 2 times 3 times 7, there are no pairs. So the square root of 42, if I said, what's the square root of 42 equal to? You'd say the square root of 42. You're right. You can't simplify it. Okay? But a to the power of 4 means I've got how many a's being multiplied? 4 of them. And b to the power of 6 means I have a total of 6 b's being multiplied to themselves. But if I'm looking for groups of 2, I got 2 of them babies. I got 1, 2, 3 of them. So here's your final answer. I have a squared b cubed radical 42. That's going to be my simplified answer. So this, you get an a that gets pulled out. You got another a that gets pulled out. That's why it's a squared. Here, you get a b pulled out, and another b pulled out. So you have b cubed. So that'll be my final answer. A squared b cubed radical 42. A squared b cubed, and then a radical 42. All right. And last one before I pause because I got another class. Okay. Square root of 18 is very easy. You just break that down into a 9 and a 2. 9 breaks down to a 3 and a 3. There's your pair. 3 radical 2 is your answer. 3 radical 2. All right, we're going to continue on this journey with the unit test. Ooh, let's take a look at this. It says, which expressions are equivalent to 5 to the power of 12 times 5 to the power of 8? Now, when you have exponents, this is called the product property. Just a quick little review. The product property allows you to take these exponents and add them together. So we're going to get 5 to the power of 20. So that's what we're looking for. Anything that's 5 to the power of 20, that's what we're going to do. Ooh, I found one. 5 to the power of 5 to the power of 4. This is called the power property, where I'm allowed to multiply them together. So that's 5 to the power of 20. So that's going to be one of my answers. Okay? And I think I found the other answer. Check this out. If I have 5 cubed times 5 squared to the power of 4, I can add those together and I get 5 to the power of 5 by adding them together. But then I have what's called the power property. I can multiply those together, and that's 5 to the power of 20. So these are exactly the same. So it says choose two answers. These are the guys that are equivalent to this expression right here. So I'm going to choose C and D. Nailed it. Ooh. Does anybody know what the square root of 64 is? The square root of 64 is just 8. right? Because 8 times 8 is 64. Well, what if I said, what's the square root of 0.64? No way. Could that just be 0.8? Yes, because 0.8 times a 0.8 or 8 tenths times 8 tenths is equal to 6,400. So I'm just going to type in a 0.8, which is 8 tenths. 8 tenths times 8 tenths is 6,400. I have a student chasing me right now. Hold on. Hold on. I got to help this student. Let me type in 0.8 real quick. 8 tenths, 0.8, because I want to get it right before I help the student. Okay, hold on. Oh man, the cubic root of 27 is 3, but I got to show you why. All right, hold on. Got to pause this. All right, so right now what I'm doing is I'm looking at what's called the cubic root. The cubic root of 27. Now 27 breaks down to 9 times 3, and 9 breaks down to 3 times 3. So 27 is also 3 times 3 times 3. Now cubic roots look for groups of 3. And I got one group of 3. So the cubic root of 27 is just 3. Why? Because 3 cubed is 27. So I'm just going to type in the number 3.
To the power.
Okay, let's take a look at this one. If you can't see it, it's x to the power of 4 over 7 to the negative 8 to the power of negative 7. This is called the power property, all right? We're got to multiply power to a power. So if I multiply power to a power, I get x to the power of negative 28 over 7 to the power of 56. Okay? Now, I need you to understand, in order to make a negative exponent positive, I can shift it down. So one of my equivalent answers could be 1 over x to the power of 28 times 7 to the power of 56. But that's not one of my answer choices, okay? Now, but if I want to make a positive exponent negative, I can move it up. So I can move that to the power of negative 56, which ends up being my answer. So what does this mean? Let me show you real quick. Ready? If I have x to the power of negative 2 over y to the power of negative 5, that's the same as saying y to the power of 5 over x to the power of 2. All right? So here's kind of the rule. If I have a over b to the power of negative 1, that just becomes b over a. So just remember, if you ever want to make a negative exponent positive, just shift it down or shift it up depending on what you want. All right, so here we have the square root of 72 z to the power of 5. Just remember, square roots look for groups of 2, so that's looking for that index is going to be a 2. Now a 72 breaks down to a 36 and a 2, and a 36 breaks down to a 6 and a 6, and I'm done. So what comes out of the radical? A 6. Z to the power of 5 breaks down to z times z times z times z times z. Whew. How many pairs do I have? One pair. Two pairs. So it becomes z squared. Well, what number do I still have left on the inside? A 2. And what variable do I still have left? A z. So this is going to be my final simplified answer. So understand, whenever you get a pair, you can pull that out of the radical. So 6z squared, radical 2z. 6z squared, radical 2z. 6z squared, radical 2z. Okay. Oh, well, that's pretty easy. We just simplified the square root of 72. So they just gave us the square root of 72. Now they're giving us another square root of 72. So I'll just do it again. 36 and 2. 6 and 6. So it just becomes 6 radical 2. Well, what if you didn't choose 36 and 2? What if you chose something else? Okay. What if you're like, I was going to choose a 9 and an 8. It'll still work. Look. 3 times 3. 4 times 2. 2 times 2, I got a pair of 3s, got a pair of 2s. 3 times 2 is 6, so it's still 6 radical 2. And that's how you get 100. All right? Good luck. Hope this was helpful. If not, just watch it again, or don't, or find somebody else to teach you.